Bright Tuty. Every student matters.
Hello children, welcome to the session. In this session children, we are going to discuss about electric circuits. So children, in this session we will discover what is an electric circuit. Then we will discuss about electric fuse and the material which is used to make a filament of the electric bulb. These are all the topics that we are going to cover in this session. But before moving ahead with our topic of electric circuit children, I would like you to recall the activity that we have done in the previous session. So children, in the previous session we discussed an activity wherein we had a cell with positive and negative terminals and we connected the wires 1 and 2 to the terminals 1 and 2 respectively. Then we had a bulb and we connected the wires 3 and 4 and later we joined the wires 1 and 3 and 2 and 4 and we said the bulb started to glow in this case, right children? Also we had done a case similar to this wherein we had connected the positive and negative terminals. Say we had this bulb and we had connected the wire 4 with wire 1 and wire 3 with wire 2, right children? And in this case also we observed that bulb started to glow. And children, we studied that bulb was glowing because we had a complete path of electric current. There was no break in the path. So we also studied about the arrangement wherein there was a break in the path of the loop or the path of the electric current. Which were those cases children? Those were, see, we had this electric bulb with positive and negative terminal. We left one terminal free. Say in this case we left the positive terminal free and we connected both the wires 3 and 4 of the bulb to the negative terminal, right? We connected it to the negative terminal. Similarly, there was a case wherein we connected both the 3 and 4 wires to the positive terminal, right? And also children, we had the case wherein we used this bulb with positive and negative terminal. Then we had the bulb and we connected only one terminal, like one wire 1 to wire 3, whereas we left the other end open. That is, we did not connected wires 2 and 4, right? There was gap. So this gap was the break in the path. Again, this is the break in the path. So children, we had studied that whenever there is break in the path of the electric circuit, whenever there is a break in the path of the electric circuit or loop of whenever there is a break in the path of the electric current or whenever there is a free terminal left, this is again a break in the loop of the electric current. The bulb did not glow. Bulb did not glow. Right children? So we concluded that bulb can glow only in the case where we have the complete circuit, wherever we had the complete loop, and this loop was known as the circuit, right children? So how can we define an electric circuit? The path made for electric current to flow. The path which is made for the electric current to flow is known as the electric circuit children, right? For example, observe this case. See, the current is going from this terminal, then it passes through the bulb and again it reaches the electric cell. So we have a complete path of electric current, and this complete path of electric current is known as children electric circuit. Okay children, and this is very very important from the exam point of view, and it can be asked as a 1 or a 2 marker children. And in this case, suppose you are asked what is an electric circuit, so you are going to write the path which is made for the electric current to flow is known as electric circuit, and the bulb glows only when the current flows through the circuit children. Okay, so whenever the current flows through this complete path, the bulb will glow. Okay children, and in case where there is a break in this path, the bulb will not glow. Okay, so let's move ahead. So children, let's read about it. See, we have an electric circuit and the direction of the current is always taken to be from positive to the negative terminal of the electric cell. See children, we have an electric cell over here which is marked positive and negative. We can also identify these positive and negative terminals. How? We have discussed that, children. This metal cap represents the positive terminal. This represents what? This represents the positive terminal. Then, children, we have the other flat disc terminal, which is marked as minus sign, and we call it as a negative terminal. We call it as a negative terminal. So, children, we consider the direction of current. We take it always a conventional direction of current, which is taken to be from positive to negative. Right, children? So that means whenever we have the complete circuit, we will observe that current always flows from positive terminal to the negative terminal. So this is the direction of current. And again, children, this is very, very important from exam point of view. Why? Because mostly this question comes as a 1 marker or a 2 marker. So children, if it comes as a 1 marker, you will just have to write the conventional direction of current is taken from positive to the negative terminal. Whereas if it comes as a 2 marker question, then children, you will have to give this circuit diagram also. Alright, children, you have to give this diagram too in case of 2 marker question.
Electric circuit. A continuous conducting path between the terminals of source of electricity, such as a cell or a battery, is called an electric circuit. Open electric circuit. An electric circuit in which flow of current stops because of open switch is called an open electric circuit. Closed electric circuit. An electric circuit in which current flows continuously because the switch is closed is called a closed electric circuit.
So children, sometimes you have a circuit which is complete and completely fine. Also children, we had to keep in mind that whenever we are making an electric circuit, we have to remove the plastic insulation from the connecting wires at both the terminals. Why, children? So that we can expose the inner metal wire, right? And we can complete the circuit, right, children? Then children, suppose we have an electric circuit. We have this cell and we can mark it as positive and negative terminal. Then we have connected these wires by removing the insulation or the plastic covers. Then we have connected it to a bulb. We have a bulb over here. One we have connected over here and the other we have connected over here. And children, by the definition of electric circuit, our circuit is complete. So the current must be flowing through the cell to the bulb, right? And the direction of the flow of current is from positive to the negative terminal, right? But sometimes you will observe that bulb will not glow even when the circuit is complete. So what could be the possible reason that bulb is not glowing? The reason can be the bulb may be fused. And children, what can be the reason of a fused bulb? Actually children, if you take a closer look at the bulb, suppose this is your bulb, you will observe a thin wire inside this bulb. And this thin wire inside the bulb is known as filament, children, okay? And sometimes what happens is, children, this filament is broken somewhere, right, children? You will, if you look carefully, you will observe that this thin filament is broken somewhere. And when it is broken, what does it mean? It means that there is a break. There is a break in the path of electric current. And whenever there is break in the path of electric current in the electric circuit, you will observe that the bulb will not glow. So children, if someone asks you that you have a complete circuit, you have a working functional cell, even then the bulb is not glowing. So children, what could be the possible reason? The possible reason could be that the bulb may be fused. And now we are going to study this in detail, right, children? So let us now read this quickly. Sometimes an electric bulb does not glow, even if it is connected to the cell properly. This may be because the bulb has fused. Let us see what could be the possible reason for the fused bulb. So children, as you can observe this diagram of a fused bulb, there is a filament in the center of the bulb, and this happens to be broken. We have a broken filament, and in this case we call it as a fused bulb. So let us now read about it. An electric bulb may fuse due to many reasons. One reason for a bulb to be fused is a break in its filament. A break in its filament. You can see the broken filament over here, right? A break in the filament of an electric bulb means, what does it mean when there is a break in the filament? The break in the path of the current between the terminals of the electric cell. It means that the path of the current is broken, children. And whenever the path of the current or the loop is broken, the bulb will not glow. Why? Because the current is not flowing or not reaching the complete loop, right? And therefore, a bulb which is fused does not light up as no current passes through the filament. Okay, children, I really hope that you would have understood the concept of a fused bulb. Okay, so let us now move ahead. So children, we have an interesting fact over here. You know that we have a bulb. Suppose we have this bulb and we have a filament in the center of it. So children, this bulb is filled with an inert gas. There is an inert gas which is argon, and it is filled, children, so that the bulb does not burn, so that the filament does not burn up when it is hot. So children, in the coming classes you will get to know that whenever there is the flow of current, heat is also generated, right? And how can you feel it? You can light a bulb for a few minutes and then switch it off. Now try to touch this bulb. You will feel that it has become a little hot, right? So it is because of the electric current. So children, whenever the current flows, heat is produced. So children, we have to carefully select the material for the making of filaments, so that it does not burns up, because if it will burn up, it will break, right? So we have to select a material which can hold very high temperatures. Even if it is switched on for many hours, it should not break. Okay, so children, we fill this bulb with an inert gas which is argon, right? And also the material of the filament is tungsten. Children, tungsten is a metal which can withstand very high temperatures and it will not melt at very high temperatures. Okay, children, so that is why you have to keep in mind what is the material used for making the filament of a bulb. So it is tungsten. Okay, and this is really interesting, guys. I really hope that you would like this, right? Let's move ahead. Now children, we will conduct one more activity. In this activity, let us see what we will be doing. So let us see, children, what we will be doing in this activity. It is a very interesting activity, children. See what we are going to do. We will take an electric cell, right, children? This is the positive terminal. And how do we identify a positive terminal? With a cap, metal cap over it. Then we have a negative terminal. Now children, what we are going to do is we will connect a connecting wire with the negative terminal of the cell, right? And the other end of this wire we will connect to the base of the bulb, right? We will tie it over here. Okay, so this is our setup for this activity. Now children, we have to make, first thing that we have to make sure is we will have to remove the insulation from the edges of the wire, so that we expose the inner metal wire for completing the electric circuit, right children? Because the metal wire will be able to conduct current. Okay, now we have connected it to the negative terminal and the other terminal is connected to the base of the bulb. Now children, what we are going to do is we will touch this base of the bulb to the positive terminal. And this is really interesting, guys. Whenever you bring this closer to the or touch the positive terminal, the bulb will glow. Why? Because whenever we touch it with the positive terminal, the circuit is completed. We will get a circuit which is complete. And whenever the circuit is complete, the bulb will light up. Okay children, now we will remove the bulb from the positive terminal. The bulb will be off. Then again we will try to touch it with the positive terminal, then bulb will again light up. So you will repeat this activity quite a few times till you understand that when we are touching it with the positive terminal, what we are doing? We are completing the circuit. We are completing the circuit, right children? So let us just read about it. Let us read this activity once. So what we are going to do is we will take a piece of wire, remove the plastic covering from its ends, connect one end of the wire to the negative terminal of the cell and the other end of the wire to the metal case of the bulb. Right children, this is what we have discussed. We have discussed that we have connected one end of the wire to the negative terminal and its other end to the base of the bulb, right? Now children, connect the tip of the bulb to the positive terminal of the cell of the wire, right? What do you observe? You will observe that the bulb will start glowing. Now disconnect the bulb by moving it away from the cell. What do you observe? You will observe that bulb does not glow. Bulb does not glow. And repeat this process many times. You will notice that the bulb glows when the tip of it connects to the positive terminal of the cell only. Okay children? So I really hope that this activity is clear to you. Now we are going to understand this with the help of a diagram. See, observe this diagram. What we have done, we have this negative terminal and we have here is the positive terminal. We have connected a wire to the negative terminal and the other wire to the base of the bulb. Now what we have done, we have touched the base of the bulb to the positive terminal and in this case bulb glows. Now we took this bulb away from the positive terminal and we observed that bulb does not glow. And why does this happen children? Because in this case we have a complete circuit, whereas in the second case we have incomplete circuit, right children? Because we have disconnected it from the positive terminal. This is the incomplete circuit, right children? I hope that you would have understood this. So let us now move ahead. Now children, we have our friend Paheli with us and she has a little different setup. What she has done, she has another arrangement of the cell of the bulb. Will the bulb glow in the following arrangement? Yes children, bulb will glow in this arrangement too because she has completed the circuit, okay, right? Just the similar way that we have done in the activity. And even if we reverse the terminals children, that is if we connect wire to the positive terminal and then we connect the other terminal to the base of the bulb and then bring the base of the bulb closer to the negative terminal, even in that case the bulb will glow. Why? Because even in that case the circuit will be completed. Okay children, so that's it guys. This is all about the electric circuit and I really hope that you would have understood the concept really well. So thank you so much for your attention.